A pot of water on two different mountains can boil at two different temperatures, even though it is the same pot and the same water. In this video we will uncover why atmospheric pressure changes water's boiling point. And we will test this with high-altitude cooking and a pressure cooker. First we will define boiling. Then we will link pressure to the boiling point. And finally we will apply that knowledge to real situations. Boiling happens when the vapor pressure of water equals the surrounding air pressure pushing on its surface. Vapor pressure is the push water molecules create when they escape into the air as steam. At sea level, where the air weighs about 100,000 pascals, roughly 1 atmosphere, this balance occurs at 100 degrees Celsius. Lowering the outside pressure lets the water win the tug-of-war sooner, so the boiling temperature drops. Raising the outside pressure makes the air win, so water must get hotter before its vapor pressure can match it. On a high mountain, the air column above you is shorter, so the pressure drops. Water may boil near 90 degrees instead of 100. The lower temperature means pasta or beans cook more slowly because the food never reaches the usual high heat. A pressure cooker traps steam, doubling the inside pressure to about 2 atmospheres. This pushes the boiling point up to roughly 120 degrees. With the water now hotter than normal, rice or tough meat soften faster, saving time and energy. Let's try a quick check. Imagine you open the cooker lid early. The pressure suddenly falls back to 1 atmosphere. The super hot water flashes into steam, and you see that dramatic cloud. This flash shows how tightly pressure and boiling point are linked. Change one, the other follows instantly. The same rule guides industrial boilers, airplane coffee makers, and even why your ears pop in an elevator. Boiling is simply the moment water's internal vapor pressure equals the external air pressure. So any change in that outside pressure shifts the required temperature. Remember, lower pressure means lower boiling. Higher pressure means higher boiling. A fact that shapes cooking, engineering, and weather. Next time you adjust a recipe on a mountain or hear a pressure cooker hiss, you will know the hidden physics behind that everyday steam. Generate your own educational videos for free at eduvids.vercel.app.